This is Mr. Martin. These are the video notes for Geometry Honors, Section 1.3. We're going to be talking about collinearity, betweenness, which is a real word, and assumptions. So some of you may know what collinearity is, um, but let's finish off our definition here. Remember, we're always going to state our definitions in conditional form, which would be if this, then that. So if points are collinear, then they lie on the same line. Squeeze that right in over there. Alright, so feel free to pause the video and see if you can write the converse based on what we were doing in the last section. So the converse would be if points lie on the same line, then they are collinear. Alright, so remember we talked about with definitions, the converse is always true. Okay, so we can say that they're reversible. Converse of a definition is always true. That is some good highlighting. Okay, so keep that in mind. Converse of the definition is always true. It's reversible. We also can say it's biconditional. So let's talk about now if points are non-collinear. I'm sure you've guessed it already. Then they do not lie on the same line. Now, question I want to ask you, see if you can figure out an answer. What's the minimum number of points that we need to use the definitions of collinear and non-collinear? So come back to class the next time I see you, and let me know if you have an answer. I may forget to ask you, so I'm going to count on you guys to remember to remind me that I asked you that question. What's the minimum number of points needed in order to use the definition of collinear and non-collinear? Alright, the converse, if you haven't already written it, if points do not lie on the same line, then they are not collinear. Right, so there's collinear, non-collinear. Now, this next section is going to be very, very important for us throughout the entire year. We're going to look at diagrams throughout the year, and there are certain things that we can assume just from looking at the pictures, and there are certain things that we cannot assume by looking at the pictures, and it's going to be, again, very important that you understand which of these you can assume and which of these you cannot assume. So the first thing that you can assume is that if you look at a picture and you see some straight angles or straight lines, you can assume that they are in fact straight. So straight angles and lines are straight. Okay, so if it looks straight, it is straight. Alright, then for number 2, we can also assume, it's kind of follows from number 1, we can assume collinearity of points. So if it looks like the points are on the same line, you can in fact assume that they are on the same line. And the next thing we can assume is betweenness of points. Again, this follows from number 2. So if points are on the same line and we can assume that, then we can assume that one point is between another point. So let me just make a little diagram here. Just a little sketch. So if I have a line here, and I've got 3 points on the line, A, B, and C. So number 1, we can assume that line AC is a straight line. even though it looks a little crooked. We can assume it's a straight line. We can assume that A, B, and C are collinear because they are all on that line. And we can assume that B is between A and C. That's what we mean by betweenness. Okay, so B is between A and C. All right, and then the last assumption is relative position of points. Okay, so going back to the diagram over here, I can assume that point A is to the left of point B, and I can assume that B is to the left and a little bit below point C, and that's what we mean by relative position of points. So all of these things, they kind of follow from one another, and those are things that we can assume just by looking at a picture. Now, moving on to the other column, things that we cannot assume. The first thing is right angles. So even though you may have a picture where the angle looks like it's a perfect right angle, unless there's some information that tells you that it's a right angle, or unless they give you information where you can prove that it's a right angle, you cannot assume that it is a right angle. Alright, and then the next one is congruent segments. Alright, so even if segments look congruent, maybe you measure them with a ruler and they come out exactly the same. If there is no information given in the problem that tells you they are, or information where you can prove that they are, you cannot assume that they are congruent. And then similar to this would be congruent angles. Same reasoning as number 2. Now, remember, if you have any questions, make sure you pause the video, write those down in your notes, and ask me the next time you see me in class. You know, with these types of lessons where you're watching the videos, it's going to be very important that you get your questions answered the next time you see me. And if you don't write them down, you're probably going to forget them. All right, and the last thing is that we cannot assume is relative size of segments and angles. Okay, it's kind of like the objects in mirror are closer than they appear. If two segments, one of them looks like it's larger than the other, but there's no information that indicates that one is larger, you can't assume that it is larger, and the same thing with angles. So keep these in mind. We're going to practice a little bit with these in one of the examples. I'm going to let you try and come up with some things from the picture that you can assume and cannot assume, and then we'll talk about them in class. Alright, moving on to triangle inequality. Given any 3 points, the points can be, there's 2 possible cases. With 3 points, the points can be collinear. So, again, here's my line. We've got x, y, and z. Alright, so if they are collinear, one point is between the other two. So here I've got point y is between x and z. And then 2 of the 3 distances add up to the third distance. So we talked about this the first day of class, that in a picture like this we have 3 segments that we can name. We can name xy, we can name yz, and we can name xz. So in this case, we see that xy plus yz, so the sum of 2 of the segments, is equal to the third segment. And if you notice here, since I'm actually talking about the measures or the lengths of the segments, I left off the segment symbols on top, so that's a little notation thing there. Alright, so that's the first possibility. If we have 3 points, they could be collinear, or they could be non-collinear. So I could have 3 points. Let's call them P, Q, and R. So I have 3 non-collinear points, in which case these points determine a triangle. So if I connect the 3 points, we get a triangle. Alright, and then based on number 2, so given any triangle, the sum of the lengths of any 2 sides is always greater than the third side. Okay, so pick any two of these sides, add them up. So let's say we have PQ plus QR. That's going to be greater than PR. Okay, or pick another two sides. Let's say we have PQ plus PR. That's going to be greater than the length of QR. Okay, so any two sides, we add them up, has to be greater than the third side. And if you think about this, if the length of these two sides was not greater than PR, then we wouldn't be able to make a triangle out of it. Okay? And if the length of these segments was equal to PR, then we would run into this first case where they would be all collinear. Alright, so example 1, you may want to pause the video and see what you can figure out here. We want to draw a diagram in which P, Q, and R are collinear, and P, S, and T are also collinear, and Q, R, and S are not collinear. So go ahead and pause the video, see what you can come up with. And I think I'm going to leave that for you to try and figure out, and we will discuss that first thing in class the next time I see you. So that's example 1. So make sure you put in a good effort on that. And then moving on to example 2, we're going to use this diagram here to make a list of things that you can assume and things that you cannot assume based on this diagram that we have here, this very fancy diagram. Okay, so see if you can come up with 2 or 3 or 4 examples of things you can assume and things you cannot assume. Again, make sure you write down any questions you have, and I'll see you in class.